Don't forget to subscribe and share. Thank you.
Thank you so much for joining us again. And we have gotten to the favorite part of mine because I love working with epsilon delta definition, how to do the manipulations and how to do the proofs. So before we get to several variables, I want us to go through just one variable to understand it before we add another variable to it. Let me see when we have x and y. So what is the epsilon delta definition? So here we are saying that limit as x is approaching a of f of x is equal to L. I'm not going to sketch the graph to explain this. I'll just go straight to the definition. So the definition is very key because we need to write it every day. So we can say that for every epsilon greater than 0, there exists there is this delta greater than 0 such that, or yeah, let me say such that whenever whenever absolute of x minus a is less than delta. So we are looking at the distance between this a and b here, right? So the distance between a and b is less than delta holds, then absolute of f of x minus absolute minus L is less than epsilon. This is my favorite definition. I love it. I think I learned it a long time ago, but I always have it. So we are looking at the distance between A and B, and when you move the L to the other side, so this is going to be something like limit x is approaching A, f of x minus L is equal to 0. So we are looking at the distance here and we are looking at the distance here, right? We are saying that this should be epsilon. Now, don't forget, epsilon is arbitrary, so it's very, very, very small, something like 0.00001. So it's almost zero, right? So that's basically the definition for one variable, epsilon delta definition. So anytime we are going to prove or solve any question, we need to write this definition down. And when we are solving it, a will be given, f of x will be given, and L will be given. So we can use them straight away in the question. So let's practice and see how we can get this done. So use the epsilon delta definition to prove that this is indeed is equal to 9. So when I do direct substitution, I'm going to get 9. Okay, so now we can go through this process. So given epsilon greater than 0, right? So you need to make sure that you write this definition quite often so that you'll be able to memorize or know this, right? So given the 0 is delta greater than 0 such that whenever whenever so here I'm looking at the distance between x and 3. So whenever absolute of x minus 3 is less than delta holds, then absolute of x squared minus 9 is less than epsilon. So when we compare this to the definition here where we have a, f of x, and L, we can see that here our a is equal to 3, our f of x is equal to x squared, and our L is equal to 9. So it's just like writing this definition and just doing substitution. So this is what you are going to get. Now, my favorite part is how to do the proof. That's my favorite part, right? So I'll start from here. So what we are going to do is we are going to pick this and we prove that it's indeed less than epsilon. So that's basically what we are going to do. So now let me start with absolute of x squared minus 9. Now this here is the same as, now don't forget, 9 is the same as 3 squared, right? I want to do it step by step so that you can understand what I'm doing here. So now this is also the same as, now I can use difference of 2 squares to write this one as absolute of x minus 3 times x plus 3, right? And we know that absolute of AB is the same as absolute of A, absolute of B, right? So we can write this one as absolute of x minus 3, absolute of x plus 3. And what we are doing here is we need to make sure that we have this distance here so that we can replace it by what? Delta. So we are fortunate enough to have this one to be the same as this. So we can say that this is less than x plus 3 epsilon. Sorry, delta, because so I'm just replacing this one by delta because this is less than, this is greater than this. So that's the reason why the sign has changed, because I'm replacing this by this and the sign is greater than, so I need to use this one, or less than, so I need to use this one here. Great. But we need to also make sure that we have this one look like this. Oh, anyway. So here we have so many ways of doing this. Now I'll show you the tricks how to get all of them. So the first one that I'm going to do will be this. Now I'll just take um x plus 3 and I can write this one as x minus 3. So I want to get x minus 3, but here is x plus 3. So what should I add to minus 3 so that I get my 3 back? 6. Great. So I add 6 to it so that I get it. So now I can use the triangle inequality. So triangle inequality says that if I have AB, then this is the same as A plus B. Sorry, this one should be less than or equal to. So I can write this one. So these are very important things that we need to be using. So it means that since I need x minus 3, I can write this one as less than or equal to absolute of x minus 3 plus absolute of 6. 6 is already positive number, so it's going to give us 6. Right. So what happens? I now can replace this one by this. So this is going to be, so this is part of the solution. Let me just add it here. So maybe say take, great. Then this is less than epsilon. So I'm going to have something like this, less than epsilon plus 6. Why am I saying epsilon in place of delta? Delta plus 6. So it means that from here, we are going to have, or let me just place this one here. From here, I'm going to replace this by this. So I'm going to have greater than delta plus 6 delta. Right. So that is what I'm going to get. So here, what I'm going to do is I'm going to choose delta very small. So I'm going to choose delta to be less than or equal to 1. So choose delta should be less than or equal to 1. So when I do that, when I replace delta by 1 here, by 1 here, I'm going to have something like this. 1 plus 6 times 1, and this is going to be 7 times 1, and this is going to be 7. So is going to be this is going to be something like, let me see. Okay, this is the same as delta squared plus 6 delta. Good. So let me do it that way first before I choose it so that you understand what I'm doing here. Good. So I expand. So here you need to pay attention to the equalities here, right? This one I'm using equal to sign because I'm expanding, and this is the same as what is here. So multiply this one by this, multiply this one by this, and this one by this, and have something like this. So now I'm choosing delta to be less than or equal to 1. So it means that here I'm going to have 1 squared plus 6 times 1, which is 1 plus 6, and this is 7. Right. So when I do that, when I choose delta to be this, then now I'm going to have this one to be greater than, right? 1 is going to be delta plus 6 delta, right? So, like, I mean, delta squared here is basically the same as delta because it's 1. So 1 squared is just 1. So that now this now become 7 delta. Great. And here, I'm also going to choose something again. So I'm going to choose here, choose epsilon to be equal to. So we choose epsilon so that we get epsilon. So this is a very simple choice to make here, right? Or let me choose delta again. Choose delta to be, so this is basically good for us to choose epsilon over 7. So you look at, you are choosing delta to be the same as epsilon, but you look at the coefficient and you use to divide. So the coefficient of delta is 7, so I divide by 7. So if it is 2, I divide by 2. If it is 1, I divide by 1. So that's basically what I'm going to get here. So it means that when I do that, I'm going to have equal to sign again because this is the same as this. And this is going to be 7 times epsilon over 7. And this is going to give us epsilon. So we can see that everything that we've done there is basically proving that this is equal to epsilon. But we've made two choices. We chose delta to be less than or equal to 1, and we chose delta to be this. So what we are going to do is we need to choose the minimum. We need to find the minimum of this so that now we can conclude on what we did. So let's choose the minimum. So choose delta to be the minimum of 1 and epsilon over 7. So when I choose the minimum of this, then now I can conclude for this. So I'm choosing the minimum of the two deltas that I chose here. So this is going to be absolute of x squared minus 9. So from here, we are up to here. So this is less than epsilon here. So this is what we are going to get when I choose my minimum to be 3. So here, since we have proven that yes, this is less than epsilon, then this is true because epsilon is arbitrary. So this is kind of like 0, and it's basically 0 from there. But let's look at another alternative way to solve this, right? I think I need to open another sheet so that we can just look at what we can do. So another way to solve this, I'm going to start this from here. Let me just copy this one and then copy this. Oops. Let me just copy this one here. But let me write my conclusion here for this one. So my conclusion, I'm going to conclude that so I'm going to say that okay, so thus this is less than this whenever whenever x minus 3 is less than delta, right? So I'm just concluding from here. So thus this is less than epsilon whenever this is less than delta. So since epsilon greater than 0 was arbitrary, we are going to conclude that limit as x is approaching 3 of x squared is equal to 9. We have so many ways of concluding this, but I love it this way. So thus, this is less than delta whenever this is less than. How am I interchanging delta and epsilon? I love epsilon and delta definition. Why? So thus, this is less than epsilon whenever this is less than delta. Then since epsilon was arbitrary, then this is supposed to be equal to 9. Now let me show you the other way too that we can solve this. So after I've gotten here, so we saw that we can just take this one and manipulate it and go through the process. Another way we can solve this one is when I get here and I want to make sure that this is not there, we can choose our definition here, right? We said this should be less than delta. So I'm just going to choose that. So I'm just going to choose x minus 3 should be less than delta. Now remember that if I have absolute of x less than 1, this is minus 1 less than x and 1. So it means that this is the same as minus delta less than x minus 3 less than delta. And because I want to get x here, I can add 3 on both sides and have minus delta plus 3. When I add 3 in the middle, I'm just going to have x, and I'm going to have this one here. So when I get this, I'm going to choose delta. So I'm going to choose delta to be less than or equal to 1. That's most of the time what we do. So when I do that, then I can replace delta by 1. So that I'm going to have minus 1 plus 3 less than x less than 1 plus 3. So this is going to be 2 less than x less than 4. Good. So I've gotten nice equation here. Now this nice equation will help me to solve this. Now let's see what happens here. Now I have absolute of x plus 3 right here, but we want to make sure that we have this one from this. So what am I going to do here? Very simple. Because I have x plus 3, I'm going to add 3 through. So I'm going to have 2 plus 3, x plus 3, 4 plus 3, right? I want to add plus 3 so that I have what is here. So this is going to be 5 less than x plus 3 less than 7. And this is the same as x plus 3 belonging to, or this is the same as this belonging to 5 and 7. But the idea is that we can write the absolute again. Here we can write the absolute and write this one as absolute of x plus 3, and we are going to choose the max. So this should be less than 7. So that's what is going to basically happen here. So you see that now if I'm doing that here, then this is going to be less than 7 delta, right? So that's basically what's going to happen here. So I'm going to have 7 delta. So don't forget we chose this one. And then here, as we did for the first one, I'm going to choose delta to be equal to epsilon. Then I divide it by the coefficient of delta, which is going to be this. So it means I'm going to have 7 times epsilon over this. And this is going to give us epsilon. So no matter the approach that you use, you should be getting you should be getting the same choice for delta, both of them. So we chose delta to be less than 1, and we chose delta to be epsilon over 7. And when you look at this one too, we chose delta to be less than 1 and epsilon over 7. So no matter where you are going to choose, no matter the approach that you are going to pass through, you should be able to get the same results. Okay, so that is basically how we are going to get. Now let's take another example so that we can see. I think I'm feeling like I didn't explain the first one very well. But let's look at two again. So we go again, giving epsilon greater than 0. There is this delta greater than 0 such that whenever, so we need to have this definition in our head. Whenever x minus 4, so I'm picking the distance between this one here, is less than delta holds, then the distance between this and this is less than epsilon. So I'm going to have absolute of x squared plus 2x in parentheses minus 24 less than epsilon. So this is our definition that we need to write, and you should be able to write this definition down. Then we start from this to prove that, okay, indeed it is less than epsilon. So this is x squared plus 2x minus 24 less than, okay, we are just starting from this. So this is what we have, but here we can do some small factorization here, because we know that x squared plus 2x minus 24, this is the same as x minus 4, x plus 6. So x times x is x squared, and then x times 6 is 6x. Minus 4x times 4 is minus 4x, which is going to give us 2x, which is here. And then minus 4 times 6 is going to give us minus 24. So we have this one here. So it means that this is the same as absolute of x minus 4, x plus 6. Absolute. Great. So the focus is on this. Always. That's where the focus is whenever we choose this one and we are proving that it's less than epsilon. So now this is the same as absolute of x minus 4, absolute of x plus 6, right? So now we can say that this is less than absolute of x plus 6 delta. So now when you get here, we have to approach the one that you want to choose, then you choose, right? So this one, I'm going to use one approach. The next one, I'm going to use different approach. That's what I'm going to do so that you'll be fluent with that and we don't spend too much time explaining all the two. So this one, I'm just going to use take. I'm just going to use take absolute of x plus 6, and this is the same as absolute of x. I need minus x minus 4, so I'm going to write x minus 4, but I need to add something to minus 4 so that I get my 6, and this is going to be basically plus 10. Good. So it means that this is going to be using triangle inequality as we learned. A plus b is the same as, it's less than or equal to a plus b. So this is a triangle inequality. So this is the same as, this is less than or equal to x minus 4 plus 10 is positive. So we are just going to have it plus 10. Great. Now we know that this is now less than delta. So we are going to have less than delta plus 10. Then we come and just plug it in here. So this is going to be less than delta plus 10 times delta, and we can expand this and have equal to sign and have delta squared plus 10 delta, and then we now can choose. So we choose delta to be less than or equal to 1, right? So that delta squared, since it's 1, we just get 1. So this is going to be less than delta plus 10 delta, and this is the same as 11 delta, right? So we want to show that is epsilon, so we need to choose delta again. So here we choose delta to be equal to epsilon, then we divide it by the coefficient of delta here, which is 11. So it means that this is going to be equal to 11 times epsilon over 11, right? So we are just doing substitution here, and this is equal to epsilon. So we have shown that this is equal to epsilon. So we are going to conclude, and let me write the conclusion here for you. Thus, absolute of x squared minus 2x or plus 2x minus 24 is less than epsilon whenever 0 is less than absolute of x minus 4, right? This one here, and it's also less than delta. So since epsilon greater than 0 was arbitrary, then limit x is approaching 4 of x squared minus plus 2x is equal to 24. So this is very simple. You just need to practice because this is just one dimension. The next video we are going to look at when we have two dimensions. So when I'm solving this one, I'm going to use different strategy to also solve this one too as well. So let's go through again, given epsilon. So I'm sure by this time you are trying to remember how to do this. There exists. So I can use this e function, which is the same as there exists. So this is the same as there exists, right? So I'm replacing it by that. So there exists delta. Delta can even depend on epsilon greater than 0, all of them, such that whenever whenever absolute of x minus 2, so the same thing here again, is less than delta holds, then absolute of 3x plus 1 minus 7 is less than epsilon. So we should be able to remember this definition. Very, very simple. We will learn how to use the several variables too as well. So let's go through the process. You can pause the video and try it and see if we are doing it right. So this is the same as 3x plus 1 minus 7. This is the same as absolute of 3x minus 6. And here I can factor 3 out. So that is what makes this very, I love this because it's kind of, you are playing around it, and always you need to find a strategy of making sure that you prove that this is indeed true, right? But always check, I didn't even check if it is true, because sometimes if this one is 9, then when you solve it, you are not going to get it to be less than epsilon. And some of the function will not depend on delta. And as soon as you get something like this, it means that you cannot use the epsilon definition to solve this particular problem here. So we know that if I have a x minus 1 absolute, then I can factor a out if a is positive. So this is basically going to be the same as 3 absolute of x minus 2. This is true, but this one we don't need to do any much manipulation because we have x minus 2 there. So this now will be less than 3 epsilon. So here our choice is just going to be 1 because you can just choose delta to be equal to epsilon divided by the coefficient of delta, which is 3. So this is going to be 3 times epsilon over 3, which is equal to epsilon. So this is very short. So we are going to conclude that thus, or hence, absolute of 3x plus 1 minus 7 is less than epsilon whenever 0 is less than absolute of x minus 2 less than delta. Now we can see that since epsilon was greater than 0 was arbitrary, then limit as x is approaching 2 of 3x plus 1 is indeed equal to 7. So it's something very simple with one dimension. Let's do this one too. This is more interesting. Now the same definition again. I love, by this time when you are working on campus, you should be able to say in it. When I meet you on campus and I ask you what is the epsilon delta definition and you can't tell me, you'll be in trouble. Okay. All right. So this is going to be epsilon greater than 0. There is this delta greater than 0 such that whenever whenever absolute of x minus 1 is less than delta holds, and we have absolute of x squared plus 2x minus 3 minus 0, because this one they just brought this one already here, so this one is supposed to be without this equal to 3. So this one is already here, so we don't need to do minus 0 because it's the same thing here, and this should be less than epsilon. So let's go through this quick and we'll do the last one. Then I give you the practice to work on it. So this is going to give us x squared plus 2x minus 3. And this is the same as, so what are the factors of x squared plus 2x minus 3? What are the factors? So this is the same as, I think it should be x minus 1, x plus 3, right? So let's try and expand this. X squared, 3x minus 1x, which is going to give us this. And okay, so this is indeed true. And this is the same as x minus 1, x plus 3. And this is less than x plus 3 delta. So I'm going to use the other approach, right? So what I'm going to do is I'm going to pick this here again. So I'm going to pick absolute of x minus 1 less than delta. Then this is the same as minus delta less than x minus 1 less than delta. Then I'm going to add plus 1 throughout. So this is going to be minus delta plus 1. When I add plus 1 in the middle here, I'm going to have this x less than delta plus 1. So here we choose delta to be less than or equal to 1. So this is going to be 0, or let me say minus 1 plus 1 less than x less than 1 plus 1. So this is 0 less than x plus less than 2. So now we want to make sure that this is plus 3. So we are going to add plus 3 out. So this is going to be plus 3, x plus 3, and this also plus 3. So this, when I do it, I'm just going to have x plus 3 less than the max, which is 5. So it means that here, I'm going to replace this one by 5 and have 5 delta, right? Don't forget this is part of the solution, but we just did it somewhere. And here we are going to choose delta to be equal to epsilon divided by the coefficient of delta here. And now we can have this one to be equal to 5 epsilon over 5, and this is equal to epsilon. So now we just do the conclusion there. I can give you another conclusion that you can use. So we can also say that thus whenever absolute of x minus, this one was 1, is less than delta, holds, then what this one is x squared, absolute of x squared plus 2x minus 3 is less than delta, right? And since epsilon was arbitrary, limit as x is approaching 1 of 2x or x squared plus 2x minus 3 is equal to 0. Indeed. So this is another way of doing this. All right. So I think that was the last example that we're supposed to do here. So solve this, and this one, because it's proof, I love to post your final solution in the MerbsConnect community for us to see if you got it right. So see you in the next video. In the next video, we are going to talk about several variables. Now we are going to talk about using the epsilon delta definition, but now with x and y. I hope you are going to enjoy it. So see you in the next video.